Okay, in this video, I'm going to go through the solutions to our test review, which again, you should find posted under U1A9. So please don't watch this video until you've tried and gone through the test review on your own. I'm going to go through the solutions pretty quickly in this video. If there's any part of this test review and you think, oh, okay, I need more practice or I'm not sure, either send me an email or go back through the unit activities to focus on what you need help on. So at the beginning, we're going to kind of fill in this table. We want to express numbers as fractions, decimals, and percents. So there's three common ways to express the same number. To turn a fraction into a decimal, I'm just dividing numerator by denominator. So 3 divided by 10 is 0.3 or 0.30. It's not necessary, but it's not incorrect either. And then as a percent, I'm just multiplying my decimal by 100. So that's 30%. Remember that percent always means out of 100. If I'm going backwards, as a decimal, 16%, I'm dividing by 100 or moving the decimal twice to 0.16. As a fraction, well, a percentage is out of 100, and then I'm going to reduce, so I can divide top and bottom by 2, but I'm not done. I can do it again. I can divide numerator and denominator by 2 again to get to my final answer, 4/25. So that's fraction, decimals, and percentage. Ratios, first of all, if I'm going to express them as a ratio, the units need to be equal. So I'm going to rewrite 2 kilometers as 2,000 meters. So 2,000 over 300 definitely isn't in lowest terms. I could divide those both by 100. So I'm left with 20 meters to 3 meters. And I don't need the units because the ratio is getting rid of the units, but that's fine. So 20 to 3 would be my ratios in lowest terms. The exponent laws, I'm going to use a as my base because a can represent any base. So the exponent laws, if I have a to the m multiplied by a to the n, so anytime I have the same base, I can just add the exponents, so that would equal m plus n. And you could show me this by an example or by writing it in long form, write out your a's and show me why you're adding them. Same thing when I'm dividing powers with the same base. We know that I'm subtracting the exponents. That's the second exponent law we learned. And again, you could show me by canceling out or putting in long form or with an example or two. The next exponent law is power to a power. So if I have a to the m raised to another power of n, then I'm multiplying a to the m n times. So I've got to do m multiplied by n. And then I think the last exponent law that we learned is any base. I'll again use a to represent it. Anything raised to 0 is equal to 1. And you can show that using either the division example or by creating a pattern. So there's lots of ways you should be able to explain the intuition behind the exponent laws. 9 times 9 times 9 would just be 9 cubed. This one, a little bit of a typographical error. I think I corrected it in the version that's online for you. This is what I wanted to write. So they share the same base. So if I'm multiplying powers as the same base, the base stays the same, and I'm just adding the exponents. 2 plus 2 is 4. And I want to leave it in power form, so I don't need to evaluate. How do I write 81 as a base of 3? Well, 3 times 3 is 9. 3 times 3 times 3 is 27. 27 times 3 is 81. So I would need 4 3's multiplied together. So that's 3 times 3 times 3 times 3, which equals 81. And I think I had some similar questions for you. We could also write 81 with a base of 9. That would just be 9 squared. Or if the base is 81, it would just be 81 to the power of 1. So those are two other ways to express 81 as powers with different bases. Evaluating means finding an answer. 4 squared is 4 times 4 is 16. You notice here the negative is not part of the base because it's not in the bracket. So it's really looking like this. So I'm going to do 3 times 3 times 3. So it'd be negative, and then my answer is 27. So the negative is only part of the base if it's included in the brackets. Here's some integer work. One thing I always do is if I have 2 signs in a row, I simplify. So I would simplify to 1 take away 12 or negative 11. Same thing here. If I have 2 of the same sign, that simplifies to a positive. 51 plus 15 is 66. Multiplying integers, if the sign is the same, it's going to be positive. A negative times a negative, so it'll be positive 30. And again, I'm just going to simplify my sign. So I have negative 2 plus 3 minus 12. So anytime I have two consecutive signs, I like to simplify. Negative 2 plus 3 is 1. 1 minus 12, again, is negative 11. I don't know why they have the same letter, but they also have the same answer. So that's work with integers. I think we have a few more integer questions on the next page. Again, if I'm multiplying integers or dividing with different signs, it'll be a negative, and then I just do 2 times 3 is 6. Negative divided by a negative is a positive. 8 divided by 2 is 4. And same thing here, different signs. So my answer will be negative. 55 divided by 11 is 5. So I'm kind of doing them in two steps. First, I'm finding the sign, and then I'm finding the product or the quotient. Now, Scott and Bill have coins in a ratio of 2 to 11. So let's look at Scott, Bill, and total. So for every 2 coins Scott has, Bill has 11, and so the total is 13. But we know in actuality there's 39 total coins. So that's 3 times as many. So I need to multiply everything by 3. So if there are 39 coins, to keep the same ratio, to keep the same relationship between 2 and 11, Scott must have 6 coins and Bill must have 33. So you can always write it in a therefore statement. Therefore, Bill has 33 coins. Again, anytime we see a percentage in math, we normally convert to a decimal. The discount is a percentage of the price. So of always means multiply. So my discount is $6. That doesn't mean I get to pay $6 for the hat. That's the value that I can take off the hat's initial price. So the hat's going to cost $14, but we pay tax in Canada. That covers part of my salary for one thing. Tax is 13%, so to find the new total, I would multiply by 1.13 to find the final price. Again, this is a good time to take out your calculator when we're working with decimals. Remember to include units, so anything with money should have a dollar sign, and then you could write, I'm not going to write it in this video, but you could write a therefore statement as well. Different ways to think about integers. One way is the number line. So if I'm moving to the left on a number line, that's a negative. But then if I'm moving back to the right, that's a positive. And so my answer would still be, I'd be 7 spaces to the left of 0, so negative 7. If you're doing something again and again and again, that's multiplication. He's gaining 5 points. That sounds good, so it's a positive. And he's doing it 2 times, so that's also a positive. And then 5 times 2 is just 10. So just kind of examples of integers kind of in our real life. Adding and subtracting, we normally think in terms of a number line or a thermometer. Multiplication is repeated actions, and division is, of course, splitting things up. One last page to the test. I'm going to show these answers using our cross multiplication method. So I find the diagonal that doesn't include the variable. I multiply those together and then divide by what's left over, what's kitty corner from n. So n is 24 times 2, which is 48, divided by 3 is 16. You could do the same thing here, multiply the diagonal that doesn't include the n. So n is equal to 3 multiplied by 7, divided by what's left over. 21 divided by 21 is just 1. In this one, you probably could have noticed that to get from 7 to 21, I have to multiply by 3. So what number times 3 is 3? Well, then n has to be 1. So whatever method you're more comfortable with works for me. Now we're going to apply our exponent rules in the last question, question 10. If I'm multiplying exponents with the same base, I'm adding the exponent. 3 plus 2 is 5. So that's writing as a single power. That's simplifying. I want to see that first. And then evaluating, you could either use your calculator or you can multiply 2 5 times in your head, which equals 32. Same thing here. They all share the same base, so I can use my exponent laws. My top simplifies to 3 plus 9 is 12. My bottom simplifies to 8. If I don't see an exponent, it's a 1. So I have negative 2 to the power of 12 divided by negative 2 to the power of 9. When I'm dividing powers to the same base, I can subtract. So again, I really need to see this. I want you to see writing as a single power, and then we evaluate. It's going to be negative 2 times negative 2 times negative 2. If I'm multiplying a negative number 3 times, it's an odd number of negatives, so my answer is negative, and then 2 times 2 times 2 is 8. Be careful in your calculator. You will need to use the bracket. So if I type in negative 2, for example, cubed, In this case, it works, but if it was an even number, I'd really need to be careful about including the brackets. So sometimes it's easier to write an expanded form and just multiply it together in your head. The last question is a little bit tough. I'll show you a couple ways to think about it. The first way is I'm going to rewrite so that I'm grouping my A's together and my B's together. Again, remember that if I don't have an exponent, we can put a 1 if that helps you. And then again, I can just use my exponent laws to simplify the top and the bottom of each bracket. So on the top, 8 plus 2, so I've got 10 A's multiplied together and 12 B's. And on the bottom, I've got 3 A's and 6 B's. And on the top and the bottom on the second bracket, already simplified. Sorry, that should be a B there. Now when I'm dividing, I'm subtracting the exponents. So I have a to the power of 7, b to the power of 6, and then I've got a to the power of 1, which I don't need to write, and b squared. And then again, I can rearrange so that my a's are together. I've got 7 a's multiplied by 1a, and 6 b's multiplied by 2 b's. So my final answer would be a to the 8, b to the 8. So this is kind of going through it in steps, using my exponent laws and my order of operations. Remembering that I can only multiply and apply the exponent laws and divide things that have the same base. So the a's together and the b's together. And again, when I'm working on a multi-step problem, I want to see the equal signs lined up on your page. One shortcut I could have done is because I'm just multiplying things together, I kind of combine this all into one operation. So I've got 8 A's, 2 A's, and 9 A's. So altogether on the top, I have 19 A's. I've got 11 B's, 1 more B, and then 9 more. So 11 plus 1 plus 9. So I've got 21 B's on top. On the bottom, I've got 1 plus 2 plus 8. So I've got 11 A's, and I've got 6 plus 7. I've got 13 B's. And now again, if I'm dividing powers with the same base, I just subtract the exponent. So I'm left with 19 minus 11 is 8. 21 minus 13 is also 8. I don't know why I keep writing A instead of B. So shortcut to get to the same place, just because when I'm multiplying, I kind of think of that as all one big fraction together. So that's a little bit of a more challenging question when we're working with variables instead of numbers, but our goal is to write things as simple as we can as single powers. Here we can't evaluate because I don't actually know values for A and B. So again, let me know if you have any questions in the comments or send me an email. And if you feel comfortable with everything we've done on this practice test, then you will be more than ready for the test that we will do at the end of this unit.